Ever since the first combustion engines were designed in the 19th century, engineers have been trying to build them bigger and more powerful. Engines are significantly more powerful today than in the past, especially the ones we'll be taking a look at in today's video. Join me for a look at the 15 most powerful engines. Number 15. Merlin 1D. From its inception, SpaceX has revolutionized the space exploration industry by turning it into something that can be done by private companies as opposed to national governments. Through its relationship with NASA, SpaceX is able to invest heavily in the development of new means of propulsion, and the most important of these is the Merlin family of rocket engines. Designed for use on the company's heavy launch vehicles, Merlin engines use a highly refined form of kerosene, known as RP1, along with liquid oxygen as propellants, and can generate an almost unbelievable amount of thrust. First flown in 2013, the latest version, known as the Merlin 1D, can produce a maximum of 190,000 pounds of force at sea level, which increases to 205,000 in a vacuum. This gives it a thrust-to-weight ratio of 180, which is extremely efficient as far as rocket engines go, and means that the Falcon 9 vehicles, which each use 18 Merlin 1D engines, are able to carry a payload of around 25 tons into space. From all accounts, the company isn't done yet, though, and the future iterations of the Merlin engines are expected to make even the 1D look small in comparison within the next decade or so. Number 14. GE9X. Aircraft require extremely powerful and reliable engines to allow them to ferry passengers and cargo around the world, and with recent drives to reduce fuel consumption in the industry, manufacturers are also trying to make them increasingly efficient too. With Boeing planning a new design of long-range aircraft known as the 777X series, it made sense that new engines would be created too, and that's where the General Electric GE9X comes in. It's a brand new high-bypass turbofan designed specifically for the 777X, and after years of testing, was first used on a flight in early 2020. By using an earlier model, the GE20, as a base, the company has increased the size of the fan and incorporated new advanced materials to improve its strength, which has allowed for higher bypass and compression ratios. This means that each one is able to produce 110,000 pounds of thrust, which is slightly lower than the GE20, but it requires at least 10% less fuel to do so. With the lighter fuselage design of the 777X, the aircraft will actually be able to fly further and faster than previous planes, while burning far less carbon. And while it's not quite an emission-free future we're striving towards, it's certainly going in the right direction. Number 13. Ferrari Tipo 0667. Formula One is the fastest racing series on Earth, and while these teams that produce the cars to compete have to adhere to strict design rules, there's usually one manufacturer that manages to squeeze more performance out than the others. In terms of the new types of engines that were introduced in 2022, it's generally believed that Ferrari have made the best ones, which are currently the most powerful used in any racing events worldwide. Known as the Tipo 0667, the V6 turbocharged engine has 4 valves per cylinder to give 24 in total, and uses E10 fuel for the combustion part, which is supplemented by an electric motor too. The engine has a capacity of 1600 cc and can reach a maximum of 15,000 rotations per minute. They can produce around 1,000 horsepower, and while these cars aren't tested for speeds in the same way as production vehicles, they can easily reach speeds of 200 miles or 321 kilometers per hour in a few seconds, and would top out much faster than that if they were ever to drive in a straight line for a long enough distance. Number 12. Shen 24. Trains are the most economical way to transport goods long distances across land, but with more and more that needs to be carried, especially in countries that are rapidly expanding, there's always a need to develop increasingly powerful engines. The current record holder was recently revealed in China and is called the Shen 24. It's the highest-powered electric locomotive ever developed and was specifically designed to pull coal trains, carrying more than 12,000 tons of material along a 165-mile or 266-kilometer-long route. The almost 350-foot or 100-meter-long locomotive has 24 axles, and it's made up of 6 sections. It boasts a unit of power of 28,800 kilowatts, which enables it to produce a forward propulsion of 2,280 kilonewtons, which eclipses the previous designs. It can pull a fully laden train of cargo at speeds of up to 75 miles or 120 kph up an incline of up to 1.2%, and features smart driving technology, which means that it can start, stop, and adjust its speed by itself to ensure it's as efficient as possible. This means the Shen 24 could operate without anyone on board and be part of a fully automated railway, but for the moment, each of the 8 in service has a driver on board just in case the systems fail. Number 11. Siemens SWT6. Open spaces and coastal areas around the world are seeing increasingly familiar structures built in them, wind turbines, and it's being seen as one of the best technologies to help us reduce our reliance on fossil fuels and move to a green future. There are plenty of pros and cons when it comes to the installation of them, and manufacturers are trying to make them as efficient as possible to make the best use of space that's available and reduce the size of the wind farms that are needed to cater to demand. The largest wind motor currently in use is the Siemens SWT6.0 154. First introduced in 2014 and designed for offshore use, these monstrous turbines have a rotor diameter of 505 feet or 154 meters, which gives them a swept area of more than 200,000 square feet or 18,600 square meters. The towerhead weighs around 360 tons, and while a large part of that is made up of blades, the engine that's driven to produce the electricity is just as weighty and efficient. It's able to produce between 6 to 8 megawatts of power when the blades are spinning at their optimal speed, meaning in theory, around 100 of these would be enough to replace a standard-sized coal power station. Number 10. Kawasaki Ninja H2R. They might be the smallest motorized vehicles on the road, but the designers of motorcycles certainly don't hold back when deciding which engines to install in their latest models. And the one that holds the record for having the most powerful engine of a production motorcycle, the Kawasaki Ninja H2R, is an absolute beast. It was released by the Japanese company in 2015 as the track-only version of the Ninja H2 and has 50% more power than the fastest street-legal bikes. Fitted with a supercharged 998cc inline-4 double-overhead cam engine, it can produce up to 326 horsepower, while the bike itself weighs 476 pounds or 216 kilos. It's the first production bike to be fitted with a supercharger, and to make this possible, a centrifugal supercharger was designed, something that generates far less heat than other types, so it's much safer on a motorcycle. During a speed record attempt at the Southern California Timing Association in August of 2018, a rider was able to unleash the full power the engine had to offer, and this allowed him to accelerate to an insane top speed of 209.4 miles or 337 kilometers per hour, which is well beyond what most race cars can achieve. Number 9. Koenigsegg Jamara. The vehicles that most of us have that use engines are, of course, cars. And while the most common ones that are owned by people around the world don't exactly rank among the most powerful, there are some production vehicles that are fitted with something far less ordinary. The Koenigsegg Jamara is one of the latest designs by the renowned Swedish sports car manufacturer and is billed as the most powerful plug-in hybrid vehicle currently available. To make this possible, the powertrain pushes the technology to the limits, and the result is incredible. At its core is a 150-pound or 7-kilo camless piston engine that's called the Tiny Friendly Giant. With 2 turbos and 3 cylinders, it produces 590 horsepower at 7,500 RPM. And in addition to this, there are 3 electric motors, which in total produce 1,100 horsepower. This gives a combined output of 1,700 horsepower and up to 2,500 pound-feet of torque, and allows the Jamara to reach a top speed of 249 miles or 400 kilometers per hour. Further to this, the way the power is generated means that it's an all-wheel drive vehicle with all-wheel steering and torque vectoring. It's undoubtedly proof that hybrid vehicles can be just as powerful as the ones that only use fuel, and that the future of electric vehicles are equally as exciting. Number 8. Lycoming XR7755. Built in 1944, the Lycoming XR7755 was, and remains, the largest piston-driven aircraft engine ever built. It was planned to be used in the so-called European bomber, which would later be known as the Convair B-36, but in the end only 2 examples were completed by 1946 when the project was terminated. technically described as being a 36-cylinder turbo-supercharged liquid-cooled star piston engine with 9 banks of 4 cylinders that were arranged at 40-degree angles. It was just over 10 feet or 3 meters long and 5 feet or just under 2 meters wide and tall, with the ability to produce 5,000 horsepower at 2,600 RPM at takeoff. The original design for the XR7755 was for it to drive a single propeller, but it soon became clear that even on the largest aircraft designs, the size that a propeller would need to be to absorb the power would have been impractical. A redesign was needed to incorporate a gearing system to drive contra-rotating propellers with adjustable speed settings and solve the problem. But by the time it was ready, the Air Force had lost interest in favor of jet engines. These new types of engines would become central to aircraft development following the war. The XR7755 is not only the most powerful, but also the most advanced aircraft piston engine ever. Number 7. GE 1750 MWE Arabelle. Holding the record for being the largest industrial turbine engine ever conceived, the GE 1750 MWE Arabelle is a steam turbine that's designed to be installed in nuclear power stations and is used to convert the steam that's produced during nuclear fission into electricity. Able to be configured depending on the power plant's precise needs, the largest blades used in these low-pressure rotors can measure up to 75 inches or 1.9 meters long, and in total, the module is 26 feet or 8 meters wide. By using longer blades, the design of the turbine increases its efficiency and allows further optimization capabilities. Because of how efficient the Arabelle design is, there are already 2 installed in China. They're also being used at new nuclear facilities across Europe and in the UK. Each of the turbines is rated to produce up to 1,900 megawatts of continuous power, and amazingly, because of how important it is for nuclear facilities to be reliable, Arabelle engines are designed to have a 99.96% reliability rate and a lifespan of 60 years. Number 6. B&W CM884WS150. Burmeister and Wain was a huge shipyard and diesel engine manufacturer in Copenhagen, Denmark, that was first established in 1846. Over almost 90 years, the designers who worked for B&W perfected their designs and became responsible for building some of the most powerful the world had ever seen. This led to the creation in 1932 of what would become the largest diesel engine on Earth for the next 30 years. The 1,540-ton engine is 82 feet or 25 meters long, 41 feet or 12.5 meters tall, and it's a 2-stroke diesel engine that runs on 8 cylinders. Amazingly, the 2.5-foot tall or 3/4 of a meter crankshaft alone weighs 154 tons, and the whole thing requires around 44 tons of lubricating oil. All of this meant that it was able to produce 22,500 horsepower, something that for the time seemed impossible and would take a long time to be beaten. Once it was built, the engine was added to the H.C. Ørsted power station, where it was used as a backup power source for when extra load was required by the network, and it's still there today. It hasn't, of course, actually been used for a long time, but could, in theory, be brought back online with only minimal maintenance. Even though it's now 90 years old, there are very few engines anywhere that weigh more than this one. Number 5. Saturn V F1 Engine. In the 1950s and 60s, the United States embarked on one of the most ambitious endeavors ever, to develop vehicles that could take people into space and eventually to the moon. It's arguably one of the greatest achievements of mankind to date and required the development of some highly advanced technology. A crucial part was the machines powerful enough to reach orbit, and on the first stage of each of the Saturn V rockets were 5 F1 engines. Designed by Rocketdyne, one of the leading rocket engine production companies at the time, the F1 remains the most powerful single combustion chamber liquid propellant rocket engine ever made. Each one is 18.5 feet or 5.6 meters long and 12.2 feet or 3.7 meters across. They burn RP1 kerosene along with liquid oxygen as the fuel, and a turbo pump was used to inject these into the combustion chamber. Delivering 15,470 gallons of RP1 and 24,800 gallons of oxygen per minute, The resulting combustion was able to produce 1.5 million pounds of thrust, and for the 2.5 minutes of operation, the 5 F1 engines were able to lift the more than 3,000-ton Saturn V vehicle to a height of 42 miles, or 68 kilometers, and to the speed of 6,100 miles, or 9,900 kilometers per hour. In comparison, each F1 produced more thrust than the combined force of the 3 main engines from the space shuttles. Number 4. High-temperature superconductor ship propulsion motor. Navy vessels are notorious for requiring hugely powerful engines that consume huge amounts of fuel to keep it operating, so it's perhaps no surprise that they too are looking at developing new electric engines to reduce their reliance on diesel fuel. In collaboration with Northrop Grumman, a new type of technology has been designed called a high-temperature superconductor ship propulsion motor, and it's currently the most powerful electric motor to have been tested by the Navy. Made up of a series of HTS wires which can carry more than 150 times the power of similar-sized copper wires, magnets are spun within the motor that in turn generate the charge that's then used to power the propellers and generate momentum, as well as providing the energy to all of the onboard electrical systems. The one that has so far been built and installed into the USS Higgins is able to generate 36.5 megawatts, or the equivalent of 49,000 horsepower, which is double the previous record from an electric motor. Spinning at 120 rotations per minute and able to produce 2.9 million newton-meters of torque, what's particularly impressive is that each of these weighs less than 75 tons, and 2 or 3 of them should in theory be enough to power a cruise ship-sized vessel or a medium-sized Navy vessel. Number 3. GE90-115B. First designed and built in 1993 as an optional engine for the Boeing 777, the GE90-115B was the largest jet engine in the world until the development of the GE9X, but remains the most powerful ever made. Created by General Electric, based on designs for the energy-efficient engine that were made for NASA in the 1970s, the base GE90 has a 10-stage high-pressure compressor that gives a pressure ratio of 23:1 and is driven by a 2-stage air-cooled turbine. The addition of a 3-stage low-pressure compressor behind the main fan acts to supercharge the core, and the fan itself is driven by a 6-stage low-pressure turbine. The GE90-115B, however, is a higher thrust variant of the engine, which means that it has a larger fan made of composite materials and a higher core power generated by adding an additional stage to the low-pressure compressor. This version then is 24 feet or 7.3 meters long, 12.5 feet or 3.8 meters wide, and weighing almost 9 tons. It's able to generate up to 115,000 pounds of thrust at takeoff. Unfortunately for General Electric, despite the GE90 being the most powerful option for the Boeing 777, most companies opted for others that were lighter. The introduction of long-range versions of the 777 meant the power was needed though, and so by 2004 they were installed as standard on the new 777 variants that were released around that time. Number 2. Bugatti 8-liter W16. If you can afford it, there's a range of street-legal cars that not only look incredible, but are far more powerful than you could possibly need while adhering to speed restrictions. But of all the engines fitted to the fastest vehicles in the world, the current record holder is the 8-liter W16 engine that's been developed by the Volkswagen Group. First released in 2005, this isn't something you'll find in most VW cars, and the only models released with it so far are the Bugatti Veyron and the Chiron, and all of their related versions. It's this engine that gives the Bugattis their insane performance stats, and with the future direction of electric vehicle design, it's likely that this will be the most powerful petrol car powertrain to ever have been developed. With a displacement of 8 liters or 488 cubic inches, this W16 has 4 turbochargers and is in effect 2 V8 engines that have been combined together on a common crankshaft. The most powerful version of the engine to so far be released was in the Bugatti Bolide, and it's able to generate an astonishing 1,825 horsepower at 7,000 RPM. The Bolide was said to be the last car to use the W16, and truly unleashed the full fury of the design, meaning that it was intended solely for track use and not meant to go anywhere near public roads. Adding the engine to the extremely lightweight bodywork of the car, it's able to accelerate from 0 to 60 or 100 kilometers per hour in just 2.2 seconds. and will reach 186 miles or 299 kilometers per hour in 7.4 seconds and has an estimated top speed in excess of 311 miles or 501 kilometers per hour. Good God. Number 1. Wärtsilä Sulzer RTflex 96C. The vast majority of world trade relies on ships to transport containers from country to country, and with increasingly congested routes and ports, companies have started turning to larger and larger vessel designs. This, of course, means that the engines that power these boats need to become larger and more powerful too, and the current record holder for the largest reciprocating engine on Earth was built for the Emma Maersk, which itself is an enormous container vessel that can carry up to 15,000 20-foot equivalent units. There are now hundreds of these giant engines installed on vessels worldwide, and it's become the go-to design for the largest of transport ships. The engine is called the Wärtsilä Sulzer RTflex 96C and was designed and built by a Finnish manufacturer. It's a turbocharged two-stroke diesel straight engine with 14 cylinders and has a 38-inch or 96-centimeter bore, an 8.2-foot or 2.5-meter stroke, and a displacement of 483 gallons or 1,828 liters per cylinder. It's enormous, measuring 44 feet or 13.5 meters tall, 87 feet or 26.6 meters long, weighs more than 2,300 tons, and it's able to produce up to 107,000 horsepower. The crankshaft of the engine alone weighs more than 300 tons, and each of the pistons are 20 feet or 20 meters tall and weigh 5.5 tons. Using as much as 250 tons of heavy fuel oil to operate per day, the engine operates at between 15 and 102 rotations per minute, and when pushed to full power, produces more than 5.5 million pound-feet of torque. Watch our Machines playlist for more top 15 videos about awesome machines. Sit back, relax, and binge watch all of our best machine videos.